This short video might answer a couple of questions that a few people have asked me recently about how to, I guess, reconcile the probability trees when the number of trials starts to get a little bit high. So we'll use an example in a moment of a coin toss, and you'll see what I mean. But Pascal's triangle, which I'll also illustrate in a moment, is a very quick way to work out how many variations there are on a particular outcome. Okay, so if you're throwing 3 coins, you've got heads and tails as an option. You might have head, head, and a tail, so it's 2 heads, but you also might have tail, head, head. Now they're both 2 heads, and they both have the same probability. The interesting thing is how often do they pop up, and Pascal's triangle can help you see that. So I've got drawn here a simple experiment. We're throwing a coin 3 times. It's been repeated 3 times. So you can only get head and tail as your answer, and as we know, the probability of either on a single toss is 1/2. So you end up working through the probability tree, going up the top here, and that's the only place where you'll get a head, head, head. And down here, the only place you can get a tail, tail, tail. And because it's going to be 1/2 times 1/2 times 1/2, you end up getting 1/8. And the same thing happens up here. Now we also know that the probability of getting each of the incremental outcomes in the middle here is also 1/8, because it's all basically made up of a bunch of halves multiplied by each other. Okay, so what we're going to look at in a moment is how we can simplify your thinking and your working in this space here. So we've got the same slide again. This time I've just written down all the various variations that can occur. Apologies for the little guy down here out of the way, but they're all about our scenarios. Okay. Now what's really important to note in this case here is you can see the HHT. That's a HTH, but they're in a way the same sort of outcomes. If you're asking yourself how often is it, or how likely is it to get 2 heads, you've got to count both of those in, and you've also got that one there. Can you see that there's going to be 1, 2, 3 lots of 1/8 that describes 2 heads and a tail? Similarly, you're going to have a head, tail, tail, a tail, head, head, and a tail, tail, head. The 3 of them, again, describing the same sort of outcome. Okay, so you can see really in this example, you've really got this one here, which is head, head, head. This one here, tail, tail, tail. And in the middle here, we have 2 other variations. In our case, they're red and they're green. So you've got 4 scenarios that you can get. So now what I'm trying to do down the bottom here is to replicate our thinking from the previous slide. See how we've got our groupings. 1 lot can only happen 1 way out of 8 outcomes, so it's 1/8. This group of outcomes can happen 3 ways, or 3/8. We've got another group of outcomes that can happen 3 ways, and we've got that last there. And you can see the number 1, 3, 3, and 1. They are the numerators of each of these fractions. And in a moment I'll go on to describe how you can use Pascal's triangle to very quickly get the 1, 3, 3, 1, and if you want to, how you can go further. So let's have a bit of a look at Pascal's triangle. It's a triangle, and the easiest way to look at it is as I've arranged it up here, where start with the number 1 at the top, and then for now we'll just put the numbers 1 after there. We could go to the definition of that, but it starts out with a triangle with little 1s there. But the way we build it down the page is we look at the numbers above it and we add them together. Can you see that the number 2 here, that's in the middle of the drawing, is made up of the 1 plus the 1. Similarly, the 3 here is made up of 1 plus 2. We just need to get into the habit of introducing ones along the side of it, down the side. Okay, so it's all ones down the sides, and the middle numbers are evaluated or put in place on the basis of adding the two above it. So again, the number 2 that we've got here in the middle of the top is got by adding 1 plus 1. Similarly, the 3 that's over here is found by adding the 2 and the 1, which is 3 equals 2 plus 1. So you jump right down the bottom, and you can construct the bottom row by going the 10 is 4 plus 6. This 10 here is also 6 and 4. The 5 is because of the 4 and 1, and that 5 over there is a 4 and 1. Now you'll notice the entire thing will be symmetrical, okay, because you really, it's a triangle in two halves. As it goes down the page, the left-hand side and the right-hand side are the same. Excuse me. How does this affect our probability trees? Well, if we come back over to here, if you think about this particular vertical slice of the probability tree, that describes if you've got 2 coins being thrown. Head-head or a tail-tail. So that's your head-head, that's your tail-tail. Can only be done one way. But this idea of a head and a tail, or a tail or a head, can be got 2 ways in the middle there. The question we just looked through on the previous slide is this here. Okay? There's only one way to throw all heads, and there's only one way to throw all tails, and that's those 2 there. But there's actually 3 ways to throw a mixture of 2 heads and a tail, and there's 3 ways to throw a mixture of the other option. Then as we work across, you get to this quite significant one here that's quite helpful to us in some other questions, because what this tells us is if we're going for our 6th trial, okay, there's going to be one way of getting everything as a head. There's going to be 6 ways, okay, of introducing a single tail into that equation. There's going to be 15 ways of introducing 2 tails. 3 tails come in there. That's quite 3 tails has got 20 ways of it happening. And then we drop down again 4 tails, 5 tails, and 6 tails. So you can use Pascal's triangle to generate the an answer to the question, how many ways can something happen inside my probability tree? Or for that matter, how many times do I need to multiply that that little number by when I do my binomial distribution? So hopefully that's helpful. I'll put some worked examples up of a question or 2 that deal with this in a moment.